Curcumin, the vibrant golden compound found in turmeric, has become one of the most closely studied natural molecules in the field of epigenetics because of its surprisingly deep ability to influence how genes behave. Instead of simply acting as an anti-inflammatory spice or antioxidant, curcumin appears to interface directly with the signals that regulate gene expression, the molecular switches that determine when certain protective pathways activate and when harmful ones quiet down. This is one of the reasons curcumin has become so strongly associated with healthier aging. It doesn't just fight symptoms, it supports the underlying cellular environment that keeps tissues resilient over time. Much of curcumin's epigenetic power comes from its ability to modulate histone acetylation and DNA methylation, two of the primary mechanisms that control gene activity. In aging tissues, both of these processes often drift into imbalance, contributing to chronic inflammation, sluggish repair processes, and metabolic inefficiencies. Curcumin has been shown in laboratory and animal studies to help normalize these patterns. It tends to quiet genes associated with inflammatory cytokines while supporting the expression of genes connected to antioxidant defense and cellular repair. This creates a biological climate that resembles the gene activity patterns of younger, healthier cells. While it does not rewrite the genome, it helps guide the epigenome towards stability, and stability is one of the foundations of slower biological aging. Inflammation is another area where curcumin demonstrates exceptional influence. Aging is heavily driven by inflammaging, the persistent, low-grade inflammation that accumulates with time and slowly erodes organ function. Curcumin interrupts this process by inhibiting NF-kappa B, a major inflammatory transcription factor that becomes overactive in aging cells. It also helps reduce oxidative stress, which is both a cause and a result of chronic inflammation. This dual action is especially valuable because oxidative stress and inflammation feed into each other, creating a cycle that accelerates biological wear. Curcumin's ability to disrupt that cycle is one of the most positive contributions it makes to long-term health. Clinical studies, though still growing in number, offer encouraging signs that curcumin may influence real biomarkers of aging. Human trials have reported improvements in inflammatory markers like CRP and IL-6, enhanced endothelial function, and better mitochondrial performance, all of which correlate with slower biological aging. Some small but meaningful studies suggest curcumin may improve telomerase activity and protect telomere integrity by reducing oxidative damage around the chromosome ends. These findings are early, but they align with the broader pattern seen across cellular and animal research. Curcumin supports systems that preserve youthfulness at the molecular level. Observational research adds another layer of positivity. Populations that regularly consume turmeric, especially in regions of India and Southeast Asia, tend to show lower rates of chronic inflammatory diseases. While diet and lifestyle patterns vary widely, the consistent presence of curcumin-rich foods in these cultures reinforces the possibility that habitual intake contributes to long-term health advantages. It is not simply the spice itself, but the way it integrates seamlessly into daily cooking that seems to matter: frequent, steady exposure rather than sporadic high doses. One especially encouraging aspect of curcumin research is how broadly beneficial it appears without causing harm when used responsibly. Its compatibility with the body's own regulatory systems makes it a gentle but powerful modulator, nudging gene expression toward balance rather than forcing it in one direction. For many people, curcumin becomes part of a dietary pattern that naturally supports healthy aging, whether through spiced vegetables, curries, golden milk, or modern formulations that enhance absorption. While curcumin is not a miracle molecule, it represents one of the most hopeful intersections of nutrition, epigenetics, and longevity science. Its ability to influence gene signaling, calm chronic inflammation, and support biomarkers associated with youthfulness paints a picture of a compound that works with the body instead of against it. As research continues, curcumin stands out as a natural, accessible way to foster cellular resilience, helping the aging process unfold more gently, more slowly, and with a greater sense of physiological harmony.